Hi, I'm Lauren with Craven Speed Performance. Today I'm going to demonstrate how we design and develop a new product for your Mini Cooper. This video shows the development of the R bracket. The R bracket was designed to accept the NUVI and TomTom GPS mounts. I'll go step by step so you can see the entire process from conception to manufacturing. The first thing we do is to remove the tachometer housing from the Mini for measuring. There's 3 holes in the back of the tachometer housing, so the first thing I'm going to do is get a measurement of these holes. Then I'm going to check the distance between the center of the holes. I want to get the spacing right. Finally, I check the depth of the holes. I turn the housing over and I get the diameter of the housing. I want everything to be as close as I can get it, so that when I get the final model, everything is right. If there are features I can't capture with mechanical instruments, I can always take it out to the optical comparator and get a good look at it. Once I have my measurements down, I can put these measurements into the computer on the modeling program and recreate a model, an exact model of the tachometer housing. Once I have the exact model of the tachometer housing, what I'll do is I will go in and start to design this new bracket. First thing I'm going to do is draw 4 circles. 3 of these circles are going to be the mounting holes that will mount on the back of the tachometer, with the 4th up in the upper right hand corner being where the NUVI will mount to, or the GPS unit will mount to. Once I have the circles drawn, I connect them all with lines and set my dimensions on the radii. And I'm going to add a few other dimensions. Oops. I'm going to go ahead and make these lines horizontal so they don't move around on me. And I'm going to go back through and make all the circles tangent to the lines. That way that'll give me a stable drawing. I'm going to go back in here and clean up these circles so they're radii instead of a complete circle. Now I'm going to finish putting dimensions in. These are the dimensions I had taken off the back of the tachometer housing. Now this is a fully dimensioned model. I'm going to add one other feature here. I'm going to put a semicircle or a radius into the outboard side of the R bracket. I drag this around a little bit to make it pleasing. Once again, I'm going to go through and make all the corners tangent, all the lines tangent to each other, so everything has a smooth transition. Go ahead and put in some final dimensions where I want this. I'm going to drag that in a little bit more, change the dimension here a little. I think I like that. So now go ahead and extrude this and give it some depth. About 1/4 of an inch would do it. I rotate it and make sure everything looks good. I like that. So now I want to add 3 mounting holes. Go back in there, and these will be in the center of the radius. All the same size, about 190 thousandths to accept the screw for mounting. Then I need to go back in and put a 1/4 20 hole on the outboard end. That's for the mounting arm. Once I've done that, I am going to draw some more lines inside, because I'm going to hollow out this shape. Remove some material. Also, I got to go through here and make all the lines and corners tangent. Give it a nice shape. Clean up little excess lines. That's a line I put in there that I ended up not needing. I'm going to take that back out. I don't like the way that's looking, so I'm going to delete that. I'm just going to draw a radius in there. Now I'm going to add some more dimensions. I'm going to make these about a 1/4 inch thick all the way around. Corners of this thing, just to make a smooth transition between all the lines, right in these corners right here. And one there, one there. That'll give it a nice flow. Okay, now that I've done that, I'm going to go ahead and extrude this shape. Cut it out. That looks good. I have one more thing left to do, and that's to put a radius on all the sharp corners. About a 30,000ths radius. Pick out all 4 corners. And that's done. Now that I'm happy with the R bracket and I have my tachometer housing, I'm going to combine the two and see how they match up. They should match up well because I took a lot of care in measuring hole locations. I can constrain these to each other. That looks good. Now I'm going to add an arm. This is an arm that we have made for a couple of years that we use on a lot of our gauge pods assemblies. Once I've added an arm, I'm going to go ahead and add a, well, that looks good. Nice little swivel there. I'm going to go ahead and add a ball joint to this. This is another ball joint. This is something that is copied after the factory NUVI mount. I designed this earlier. I won't take you through that process. That's a set screw. It's a 1/4 set screw that we use. Put that ball back on. The next part I'm going to add here is actually the factory NUVI clip. It mounts onto our ball. I drew this after measuring the factory clip, so I can make sure everything was going to fit together. Now I'm going to add the R drawing of the NUVI. This is made after taking measurements of the actual size of the NUVI. So I can look at that, and I'll put it face forward. I can swivel it. See how many degrees of rotation this has. That looks good. There's a nice degree of freedom. Good movement. That all looks good. So now I'm ready to move on to the next step, just to get this designed for machining. So now I can direct import that model that we made of the R bracket right into our cam system. There it is. Now we're going to make these 2 at a time, so that's why we're using a longer piece of stock. We can select our tools and replicate the actual machining process. We were cutting out the inside pockets on 2 of these R brackets. Then we're going to go out and do the outside of it. Put all the holes in, break the edges. Once that's all checked out, we can go ahead and create the code for the machining. In Chapter 2, we'll take this part out to the machine shop and get started on the machining process. Stay tuned.